Hello, colleagues. So the topic of our paper is the mathematical modeling of the Braille font formation for the information and communication environment creation for blind people. So in 2015, there were approximately 253 million people with visual impairments worldwide. This quantity included 36 million of blind persons, and another 217 million persons had medium and high level of visual impairment. And in 2020, there were approximately 295 million of visually impaired people worldwide. This number included 43.3 million of blind persons, and another 251.7 million had medium and high level of visual impairments. So in total, by 2050, there may be approximately 203 million people who will be blind or have medium and high level of visual impairment. For almost 2 centuries, people with visual impairments all over the world have been using dot relief writing, which was invented by the blind French pedagogue Louis Braille in 1824. So regulatory documents, for example, Braille on folding cartoons, European Cartoon Makers Association, 2005, research works dedicated to the perception of the Braille font, tactile graphics, resistance of the Braille font to loads, electronic systems contain the definition that the reliability of reading information by people with vision impairments depends on the height of the Braille font element. Lots of different technologies are applied for the printing with Braille, but one of the most promising technologies is the stencil printing method, which allows to receive thick image layers. And as a stencil printing method is a complex process that is influenced by a significant number of factors, it is important to determine the importance of these factors, mathematical modeling, and the usage of statistical analysis methods in the research of the influence of individual technological factors on the quality of the print. So nowadays, IT market offers high-quality applications with a perfect and multifunctional service of the corresponding tools among the software products for data analysis. We use the statistical software complex developed by StatSoft from USA for processing and analyzing of the received experimental data. This software package is well known among experimenters, analysts, scientists, and other specialists who work with big data, carry out their systematization and modeling. The package is characterized with user-friendly interface, providing a wide range of analysis tools from determining correlations, scatter diagrams, plotting distribution graphs, to exploratory data analysis, neural networks, process analysis, and allows interactive visualization of results. And methods of correlation and regression analysis are the most developed methods of mathematical statistics. They are used to study statistical connections, including identifying the form of the connection and determining its strengths. The main goal in the application of correlation analysis is to identify an estimate of the strengths of the connection between random variables characteristics that characterize a certain real process or object. It does not establish the causes of dependence between studied characteristics, but only reveals the existence of the dependent itself, its strengths and direction. Regression analysis examines the form of dependence, which is the model of connection expressed in the regression function between independent variables. So the aim of the paper is to determine the dependence between the main factors of stencil printing that ensures the necessary height of the Braille font for the tactile perception on the basis of experimental research with the usage of the regression and correlation methods. Stencil printing forms with a minimum thickness of the copying layer with an increased thickness of the copying layer above the grid at 100 and 200 micrograms. Were used in the research. The thickness of the dry ink on the print depends on the coefficient of the dry residue content, which can vary from 20 to 100%. The thickness of the raw ink on the print and the spreading coefficient of the ink, which is 0.5 to 1, and the absorption coefficient, which is in the range from 0.5 to 1. Our main results. A regression analysis of the technological process that uses a stencil form was carried out. It was found that the dependence of the thickness of the dry ink layer on the print it depends on the thickness of the raw paint on the impression, and the dry residue content ratio is linear since the coefficient of determination is 0.98, which is a high value for the for this process. Correlation analysis of the interconnection between the technological process of using the stencil form and the minimal copying layer was carried out. The results show that there is a direct linear dependence between TDLP and TRIP, where the partial correlation coefficient is 0.99. However, such a dependence was not found between TDLP and the coefficient of the dry residue content, where the partial correlation coefficient is 0.58. Prior to this, TRIP has a greater effect on TDLP, that is 0.94, while the coefficient of the dry residue content affects less. So the next step there was perform the regression analysis of the technological process with the usage of the stencil form and the minimal copying layer. This analysis specifies the dependence of the thickness of the dry ink layer on the print from the thickness of the raw ink on the print. And the coefficient of the dry residue content is linear, considering the fact that the coefficient of determination, R2, is high and is equal to 0.96. Also, there was conducted the correlation analysis of the technological process with the usage of the stencil form and the minimal copying layer. The result indicates that there is a direct dependence of the TDLP from TRIP, where the partial correlation coefficient is equal to 0.98, and the dry residue content coefficient, where the partial correlation coefficient is equal to 0.7. In parallel, TDLP is more strongly influenced by TRIP and less by the coefficient of dry residue content. So the next move was carrying out of the regression analysis with the usage of the stencil form, where the copying layer exceeds the thickness of the grid by 100 micrograms. This analysis shows that the dependence of the thickness of the dry ink layer on the print from the thickness of the raw ink on the print and the coefficient of the dry residue content is linear, since the coefficient of determination is equal to 0.98, and this value is high. So let's move on. After that, there was performed the correlation analysis of the technological process with the usage of the stencil printing form, and the 100 micrometer thick copy layer is above or thicker than the grid. This analysis indicates the presence of a reliable direct dependence of TDLP from TRIP. In this case, the partial correlation coefficient is equal to 0.99, and a moderate linear dependence from the dry residue content coefficient, where the partial correlation coefficient is equal to 0.59. In this time, TDLP is more strongly influenced by TRIP, which is equal to 0.94, and less by the coefficient of the dry residue content, which is equal to 0.11. So the further step was to provide the regression analysis of the technological process with the usage of the stencil printing form, and the copying layer surpasses the thickness of the grid by 100 micrograms. This step shows that the dependence of the thickness of the dry ink layer on the print from the thickness of the raw ink on the print, and the coefficient of the dry residue content is linear, as the coefficient of determination is equal to 0.96, and this value is high. So, and let's move on to the final part of our main results. So then the correlation analysis of the technological process with the usage of the stencil printing form, where the copying layer surpasses the thickness of the grid by 100 micrograms, was conducted. This stage indicates the presence of a reliable direct linear dependence of TDLP from TRIP. In this case, the partial correlation coefficient is equal to 0.98, and from the dry residue content coefficient, where the partial correlation coefficient is equal to 0.72. At the same time, TDLP is more strongly influenced by TRIP, which is 0.95, and less by the coefficient of the dry residue content, which is 0.22. Okay, and our main conclusions are that a significant number of new and improved technologies have been developed to reproduce Braille. The main task of these technologies is to ensure the reproduction of Braille elements of the appropriate height for high-quality perception by people with visual impairments. And one of the methods of provision is stencil printing, which requires mathematical modeling of the effect of printing processes on the reproduction of the Braille elements height. Regression analysis work was carried out for two types of stencil printing forms with different thickness of the copying layer. This analysis was also carried out in cases where the spreading and absorption coefficients were equal and opposite. As a result, a linear dependence between the thickness of the dry and raw ink layer of the relief dot image on the print was determined, as well as the coefficient of the content of the dry residue. With the help of the modeling of the Braille printing process, the relationship between the parameters of the printing process was determined. And the results of experimental studies show that the height of relief dot images, thickness of the dry ink layer on the print, exceeds 100 micrograms, which ensures tactile perception of Braille by people with visual impairments. Thank you very much for your attention.